Warm wishes and greetings to everyone present here. Today we are going to see about the how the maximum shear stress and bending stress occur. The case of a simply supported beam, so which is of 10 kilonewton of eccentric load, which is 3 meter from the left hand support and 2 meter from the right hand support. The load is 10 kilonewton acting at point C. The left support is A and the right support is B. Under the point load, the point is C. Now, the reaction for this simply supported beam carrying an eccentric load of 10 kilonewton at the support A is 10 into 2 divided by the span is 5. That is equal to 20 divided by 5. We are getting 4 kilonewton. So the reaction at the support A, this is support B. At the support A is 4 kilonewton, and this reaction at B, that is VB or RB, is equal to the load 10 into this span is 2, this span is 3 meter, so 10 into 3 30 divided by span is 5, so 30 divided by 5 6 kilonewton. So near the load the reaction is more, so which is 6 kilonewton upward, and at the support A the reaction is 4 kilonewton. If you add upward reaction is 6 plus 4 10, that is equal to downward load of 10 kilonewton external load. So after that we have to find the maximum shear force and where it occurs. So the shear force diagram, if you draw at the support A, that is the I am taken some section left of A, it is 4 kilonewton, left of is positive shear force 4, then up to the left of C, it is 4 kilonewton constant from A to C. Then at the right of 10 kilonewton downward load, what will happen? 4 minus 10. So it is a downward shear force of 6 kilonewton. Then similarly at the support B, right? So I am taking right section, what will happen? Upward. So right section upward is negative. So minus 6 kilonewton. So this is for the horizontal line AB. So at the left end of support we are having 4 kilonewton constant. After that it will goes to right negative shear force, which is of 6 kilonewton. Rectangle of here 4 kilonewton up to A to C, then C to B it is 6 kilonewton. So here the maximum shear force is 6 kilonewton. Then how to find the maximum shear stress? The given beam is of a rectangular section which is of width 300 mm and depth is 500 mm. So for a rectangular beam, the moment of inertia about the neutral axis is B dq by 12. So here B is 300 into 500 cube by 12 in terms of millimeter to the power 4. Then maximum shear stress for rectangular beam is 3 by 2 Q average. So 3 by 2 into shear force maximum is 6 kilonewton. So convert it to Newton, 3 by 2 into 6 into 1000 divided by area is what? 300 into 500 for the rectangular beam. So 3 by 2 into 6 into 1000 divided by 300 into 400 cube by 12. So if you are calculating the numerical value, so you will get the corresponding value of the maximum shear force, so which is of 0.56 Newton per square millimeter. So if you are taking a rectangle, if you are drawing the shear stress distribution diagram, so vertical line, so you can take this as stand as a vertical line. So what will happen? This is the neutral axis which is passing at the centroid, right? Above it you get 0 shear stress. Here also shear stress. Here you are getting right 3 by 2 Q average, that is 3 by 2 into 6000 divided by 300 into 500 cube. So we are getting a 0.56 Newton per square millimeter. So at the neutral axis, that is the middle of this point, we are getting a maximum shear stress. It is of parabolic curve. It is of parabolic curve. 0 at the top and bottom and maximum at the middle, that is neutral axis, it's of 0.58 Newton per square millimeter. So this is about the maximum shear stress. in a case of simply supported beam with eccentric load and a shear stress distribution diagram. Then what about the maximum bending moment? So the maximum bending moment occurs under the load, that is at C, which is of WAB by L. So here W is equal to 10 into A, the distance A from the left support is 3. 10 into 3 into the right hand B is 2. Right? 3 into 2, 6. 6 into 10, 60 divided by L. L is equal to 5 meter. 60 divided by 5, what will happen? So it is 16. So the maximum minimum is 16 kilonewton meter. 16 kilonewton meter is the maximum bending moment. So what about the maximum bending stress? The maximum bending stress occurs. So this is the vertical line, top and bottom fiber, neutral axis. The maximum bending stress occurs to the top fiber and bottom fiber. So which is of, we have to calculate what is that? From the basic pure bending equation of the first two term, m by I is equal to, right, sigma by y. So here sigma max is equal to maximum bending stress occurs, right, at the top and bottom fiber with the maximum bending moment at the midspan, which is of 16 kilonewton meter. So m by I into y max. So m max is equal to maximum bending moment is 16 into 10 power 6 divided by I is 300 into 500 cube by 12 into I max is 500 by 2, that is 250. So it is 16 into 10 power 6 divided by 300 into 500 cube into 250. So if you are working hard, you will get around 5.75 Newton per square millimeter. So the maximum bending stress, right, occurs at the top and bottom. So here it is 0 vertical line. So maximum, that is a triangle, and 0 at the neutral axis, right? Then it will come as the tensile stress from middle to, that is a neutral axis, to the bottom fiber. So which is of maximum of, right, 5.75 Newton per square millimeter. The triangular portion, it is here the triangular portion like this, because simply supported compressive stress from above neutral axis to the top fiber, which is of compressive stress of bending stress 5.75 Newton per square millimeter at the bottom, right? If you are taking it again a triangle 0 at the neutral axis and a maximum at the bottom fiber, which is of 5.75 Newton per square meter of the tensile stress in case of the maximum bending moment. So this is about how we are getting the maximum shear stress bending stress after calculating the reaction and maximum shear force and bending moment for a given simply supported beam with an eccentric point load of 10 kilonewton, which is at a distance of 3 meter from the left support and 2 meter from the right hand support. So this is about the problem solving for a given simply supported beam with an eccentric point load. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.